Today, on how it's made. Whips. Automatic pizza makers. Incense cones. And model jet engines. In the old days, ranchers used the sound of the whip to move cattle. Today, collectors buy different types as functional works of art, while others practice the sport of whip cracking, training to compete in competitions. There are even entertainers who perform eye-popping tricks with whips. In the world of whip cracking, the best whips are made of kangaroo leather because it's 10 times stronger than cowhide of equal thickness. Modern whips have 4 main parts: the handle, the thong, which is the flexible braided portion, the fall, a replaceable strip of leather, and the cracker, the thin string which amplifies the sound of the crack. After carefully selecting the hide to be used for the specific whip, they begin by trimming away the ragged edges of the kangaroo hide with a razor-sharp knife. This leaves a smooth edge with which to work. They now begin cutting out all the whip's leather components, most of which have strands which they'll later braid. The internal construction of the whip is made of 2 layers of braiding called plaited bellies. Separating each braided layer is a solid piece of leather called a bolster. It encircles the braided belly layer under it. Then, covering everything, is a final outer layer of braiding called the overlay. They cut the strands for the bellies and overlay by hand, using a tapering cutter that's specially designed for whip making. The finished overlay and bellies have a flat portion at the top called the yoke, and strands tapering continuously along their entire length. They stretch each strand as much as possible to ensure the braid will be tight and uniform. Then they resize each strand and bevel its edges. This helps the strands fit into each other snugly and create a smoother, gapless braid. Using a tool called a hand splitter, they shave the backside of each strand to a uniform thickness. This prevents lumps in the taper of the finished whip. Next, they take waxed cord and tightly bind a tapered strip of leather around a handle foundation. The leather strip, called the core, will extend into the center of the thong. They attach the first belly yoke over the handle and core, then braid the strands to begin forming the thong. This compresses the core into a solid round center. Over the braided first belly, they wrap the first bolster and attach and braid the second belly. Over that, they wrap the second bolster, each layer compressing the ones underneath. Then at last, the final layer, the overlay. First, they lubricate the strands with homemade animal fat-based soap. This not only enables a tighter braid, the animal fat also conditions the leather. This particular whip has a 12-strand overlay, but more intricate overlays can have as many as 72 strands, forming complex patterns. While braiding, it's critical to seat and align the inner layers and pull the strands tightly. When the thong reaches the finished length, they feed the end of the braiding through a slit in the next part of the whip, the fall. They tie the remaining strands in sequence around the fall, using what's known as a half-hitch knot. Then they seat the fall into place and trim the loose strands. This creates a secure connection between these 2 sections of the whip. Now they roll the thong between a hard surface and a block of marble. This compacts the braiding and rounds out the overall shape. Then they tie the cracker onto the tip of the fall. In the old days, they used horsehair for the cracker, also known as the popper. Nowadays, whip makers are more likely to use nylon string. They wrap a piece of leather to build a knot foundation at the base of the handle. For longer and thicker whips, they form the knot foundation with a piece of lead to properly balance the whip. They fold the yoke from the overlay over the foundation, then, with a separate strand of leather, cover the foundation with what's known as a Turk's head knot. After trimming the knot strands, they shape the knot with a soft mallet. Then, more rolling. Lastly, they apply a coat of natural shellac to the entire whip. This protects the materials and produces a nice sheen. No whip leaves the shop without a round of hands-on testing to make absolutely sure it's all it's cracked up to be. If you have a craving for Italian and there's no restaurant in sight, you can always buy a pizza from a vending machine. Not something pre-made and packaged that you have to reheat in the microwave, but a fresh pizza made from scratch right inside the machine and served to you piping hot. This automatic pizza-making machine produces a fresh pizza in less than 3 minutes. You simply insert money, then select one of 4 different pizza toppings. The machine then makes the dough, applies the toppings, and bakes the pizza right before your eyes. When it's ready, your made-to-order 27-centimeter round meal is ready for pickup at the exit slot. To build the machine, they first construct a 3-section steel frame. Technicians install a refrigerator in the middle section. The fridge houses 4 dispensers, one for each of the 4 topping ingredients. The machine presses and dresses the pizza dough on a non-stick plate, around which they assemble a housing. A motorized tray moves the plate in and out of the housing to transfer the dough from one preparation stage to the next. Technicians install this assembled unit into the left section of the frame. Next, they install the dough mixer above it. And just below the mixer, a plastic cup, which receives the kneaded dough, then drops it onto the press plate. Next, the flour dispenser. It holds enough flour to make dough for 100 pizzas. Still in the left section behind the flour dispenser, they install and load the tomato sauce dispenser and a bag of water. Then in the right section, they install the oven. And below that, the pizza exit slot. Once everything's hooked up, a test run. The action begins in the left section. The flour dispenser releases a dose of flour, which is actually a mix of various flours, instant yeast, and salt. Then the water bag releases a dose of water. The mixer blends and kneads all the ingredients. Once the wad of dough is ready, it drops from the mixer into the cup. A descending arm pushes it from the cup onto the press plate, forming a 10-centimeter disc. Then a large press flattens it out to 27 centimeters, the finished pizza size. Now the tomato sauce dispenser rotates, squirting tomato sauce onto the dough in concentric circles. Next, the pizza travels through the middle section, passing beneath the refrigerator to receive the selected toppings, in this case, cheese. Then, a large automated spatula, called a conveyor plate, moves the pizza to the right side section, into the machine's infrared oven. Infrared radiation works faster than traditional heating because it cooks food from the inside out rather than from the outside in, so the pizza bakes in just 1 minute. The conveyor plate returns, removes the hot pizza from the oven, and deposits it in a cardboard tray waiting in the exit slot. Cueing flashing lights, inviting you to come and get it. Once a test run produces a perfect pizza, the final step is to mount the doors on the self-service pizzeria. Buon appetito! Burning incense is a ritual as old as time itself. It likely began with the discovery that burning certain plants and tree barks generated pleasant aromas. Eventually, people began compressing those sweet smells into cone incense, which burned slowly, giving the user more time to relax. Lighting an incense cone can instantly change the mood in a room. As the cone smolders, it releases a bouquet of scents from the powdered flowers, herbs, and other plants used to make it. The fragrances released create a soothing atmosphere. An incense cone starts with bins of aromatic raw materials, like dried flower petals, spruce tree needles, and blossoms that have been ground to a fine powder to release their perfumes. Other ingredients in the bins include tree barks and tree resins. Everything comes from nature. The factory combines the ingredients in various formulations, depending on the incense cone recipe. The exact amounts in each recipe are closely guarded company secrets. They follow each recipe to the letter, measuring all the ingredients with a traditional balanced scale. There's no room for error, otherwise the product will smell off. This particular blend is called forest honey. The combination of ingredients includes berries and a pungent balsamic tree resin called olibanum. The batch should emit a sweet woodsy aroma. They add buckets of the measured ingredients to a mixer and then turn the switch to activate the auger. The auger spirals to evenly distribute all the aromatic ingredients. While that's happening, a worker scoops up something that looks a lot like pastry flour, but is actually a plant-based binding agent. He mixes it with cold water to liquefy the binder. Then, in a separate pot, he adds orange food coloring to boiling water, and an automated whisk mixes thoroughly. He pours the thick binder liquid into the orange-colored water. The whisk kneads it to a pudding-like consistency. It's thick and sticky, so it's ready to add to the dried fragrance mix. The auger works it into a cakey orange dough that's as malleable as putty. They'll now use this two-part die to shape the dough into cones. The worker manually presses the fragrant dough into the cavities of the die. He compacts the dough with this handy tool. This eliminates air pockets and ensures the dough takes the cone shape. He levels the bottoms of the incense cones and then opens the die carefully. The shapes are soft and delicate. One false move and he could destroy some of the cones. The cautionary approach pays off and the cones are intact. Now it's into the drying chamber. The temperature in here is around 38 degrees Celsius, hot enough to toughen up these soft and crumbly cones. After 4 days in the drying chamber, the incense cones have hardened and solidified. The cones now bounce along a conveyor, past an inspector who sorts out any defective ones. The good ones move forward and tumble down a chute. They land in a plastic bag, and a device moves in to heat seal it. An automated counter overhead portions out the cones to ensure the correct number is deposited in each package. After a worker puts the bag in a box, an automated device folds down the lid. From start to finish, it takes about 14 days to produce a package of incense cones. All that hard work is about to go up in sweet-smelling smoke, which of course is the whole idea. The model jet engine is a scaled-down version of the real thing. It's essentially the same technology that lifts enormous aircraft off the ground and propels them through the sky. These engines were first developed for model aircraft in the 1980s, and they created an immediate sensation on the runway. For some model aircraft enthusiasts, tiny turbines are now the only way to fly, because they look and sound like a real turbojet. It's a touch of authenticity that can allow the imagination to really take off. These mini-jets start with the base plate. It's the piece that all the other turbine parts will be attached to. Automated tools transform a piece of aluminum into an aerodynamic shape. The little blades cut into the perimeter will act as airfoils, contributing to lift and thrust. It takes just minutes to go from a metal disc the size of a hockey puck to a precision part. Next, a worker laser welds the seams of a steel canister, creating what looks like a large can with holes. This is the jet engine's combustion chamber, where a mix of fuel and air will be ignited to drive the turbine. He now inserts a hollow cylinder into the base plate, and then presses a fuel distribution ring into the plate. With the parts correctly aligned, he places the assembly in a metal stand. He dips screws in a thread-locking compound and drives them into threaded slots in the base plate. This secures and cements the base plate assembly. He now holds the base plate unit above the combustion chamber while he inserts the tiny fuel delivery tubes into the chamber. He flips the chamber around to slide the tubes further inside and complete the job. The stator vane, pressed onto the other end of the chamber, will redirect the flow of gases to the turbine wheel. And now, the glow plug, so named because it glows to ignite the fuel inside. He pops it into a threaded slot on the side of the combustion chamber, which is by now encased in an outer shell. He installs the turbine and shaft, sliding the shaft into the center cylinder. He supports the shaft on both ends with thrust bearings and washers, pressing the parts into place. Next is the compressor wheel, which pressurizes air on its way into the chamber. Once installed, the compressor wheel spins at a blurring speed, and a computer analyzes it for the slightest vibration. Any vibration would signify an imbalance. The technician drills away tiny bits of metal to lighten the area of imbalance. The exact spot was pinpointed by the computer. He gives the compressor wheel another spin. Again, the computer detects a small imbalance, and more material must be removed. This process is repeated several times until the compressor wheel is perfectly balanced, and the computer gives it the green light. After that, he balances the turbine wheel on the other end of the shaft. This mini jet engine is now ready for the starter motor. He installs it on the shaft protruding from the compressor and anchors it with screws. Once in place, it will spin the shaft until enough compressed air is produced to ignite the fuel. This plastic tubing will deliver gas to the engine and oil for lubrication. He adds a little of the oil for the initial lubrication of the bearings. Next, he heats one end with a lighter. This makes the plastic supple so it easily fits onto the connector. He wires the starter to a battery and tests the motor. It works, so he snaps an aluminum cover onto the assembly. This model jet engine is ready for the final test. Locked down in a test box, they pump fuel into it and bring it up to full throttle. Using computerized equipment, the technician monitors the output and confirms the engine is producing an adequate amount of thrust. That means it's ready to leave the factory and take flight. In total, it takes about 6 hours to make a model jet engine, but after that, the sky is the limit.